This is Copier Machine, an app that's in Ornament and Crime. It's a cascaded 4-stage sample and hold module that has a quantizer and is an analog shift register. That sounds very technical and complicated. So in this video, I'm going to show you how it works, how you can use it in your patches, and some tips and tricks for getting the most from it. Let's get started. The best way to understand how Copier Machine works is to use a simple graphical example. We start by looking at an input source, CV1, which is being sampled by a sample and hold module. The sample and hold module takes periodic measurements of the input signal and uses that to input into a circular buffer, represented by this conveyor belt. Values are moving along through the circular buffer, just as they would a real conveyor belt. The speed that they're moving at is controlled by the clock input, which is this metronome. As values come off the conveyor belt, they're quantized to a scale using a quantizer. The output from the quantizer is sent round robin between outputs A, B, C and D. That's the little robot arm here. Each clock tick, it's taking the next value off the conveyor belt and sending it out the next output. The output value at A moves to B, and then to C, and then to D, before disappearing. These output values can be used to send pitch information to oscillators, or can be used as modulation sources in your patch. All of these can be modulated using control voltage inputs. But there are also other modes available which we'll see later on, including a linear feedback shift register mode, a byte beat mode, and an integer sequence mode, all of which generate their own internal values to go on the conveyor belt. Now let's look at how we can use the Copier Machine with the sampling, the external CV. To demonstrate this, I'm going to use the key step as a sequencer to send pitch and gate information into Copier Machine, which we'll use to drive the shift register. Let's get the patch wired up. The gate. So here I have the gate output from my key step. I'm just going to mult it into two places using this starfish mult here. First of all, I'm going to send it into this Doepfer envelope generator, which we're going to use to actually control the VCAs here in ripples and plates. And I'm also going to send it into trigger 1. Now let's send in a voltage to sample. So we're going to use this red cable here. This patch cable is the pitch information. And now if I wanted to actually use the arpeggiator mode on the key step, I could send in an arpeggio. And because I have hold active, the key step will just keep playing that arpeggio. So this is great. Now I've got a sequencer running away, sending in both gate information here and also triggering these envelopes and also sending in voltages. Let's make some sounds with this. Okay, so first of all, let's patch the first output into the voltage level there of the plates, and then we're going to take the output of this first envelope into the level. I will then patch the main output into channel 1 of my stereo mixer. Oh, hello, we can hear. Let's patch the auxiliary output over here onto the right channel. Now what we're hearing here is just basically the notes in the sequencer. Let's also wire in the MCO on output 4. So I'm going to send that the volt per octave input, and we'll just send this into here. I'll patch the output of this second envelope generator into the gain output here. Because the ripples has a VCA and filter built in, it's quite handy. 2 modules, price of 1, and I'm going to patch that into there. Now when I hit play some sequence, so what if we wanted to freeze the buffer? What if we really liked what was in there and we wanted to freeze it and then just play around with what was recorded in? We'll keep on sending in gate information, or we're not going to send in any new note information. Trigger input 2, if it gets a high gate, will freeze the buffer. And once the buffer is frozen, the contents in it don't change, but you can manipulate them and send out different CV values. So we've got two voices set up. We've got it all routed from an audio point of view. How are we going to freeze that buffer? For that, I'm just going to use this 4-step sequential switch, which is from ST Modular. I really like this for its hands-on playability. And I've just configured the first 2 steps as a 2-step switch. When I press this button, it'll oscillate between them. First step is 0 volts, second step is 5 volts, so it's basically a simple on-off switch. I'm going to patch the output of that into trigger 2, and now when I press this, it's going to freeze the contents of the buffer. So I'm going to use my 2-step switch here as an on-off. I'm going to set it to off, so right now the notes I play in the key step are going to be recorded into the buffer. Now I'm going to freeze the buffer. Now I can go in and manipulate what's in it. First, let's change the mask. Now I'm just changing the scale mask here. And it has a dramatic change already in the notes being produced. I can also go in and repitch. And again, I'm just cycling through what's in the buffer. But the real fun starts when you start to play around with the buffer index. This is like a delay, sort of. It's picking the values at different steps out of the buffer to send out of the outputs. You see, by changing it, I change the pattern of the notes very dramatically. I've changed the buffer hold. This is the amount of steps in the hold buffer. The full buffer is 256 steps long. I'm just holding the last 8 notes. I could change that to 16 or 12 or whatever I want. I can also scale the notes coming out of the buffer, reducing them, so reducing the range of CV values produced, or increasing it all the way up to a 2x multiplier. Now, these are all great functions to play around with the buffer when you are able to get to the module and look on the screen. But what if you wanted to have more automatic control over some of these? Well, the nice thing is you can actually choose a modulation source, which will come in on CV4 here, and send it to one of a number of different aspects of how this buffer is being manipulated. So obviously you can repitch it from the octave, change the root note, transpose it, change the buffer length, or change that gain, that input gain. Let's play around with the buffer length. Now, what I'm going to do is patch the mod wheel strip here on the key step into CV input 4. And then when we play, now remember again, the buffer is frozen, so the notes I entered on the key step don't matter. All I'm doing is sending in gate triggers to it to cycle the buffer. Now I'm playing around with the length by sliding my finger on the key steps mod strip. But there are other ways of generating random voltages on these outputs that don't rely on a control voltage being sampled. You get to it from this CV source menu, and now we're going to look at all the different types. There's byte beats, an integer sequence, and there's a standard feedback shift register. When you select CV source byte beats, you now get a whole additional set of parameters here. Byte beats are algorithmically generated melodies. So you could think of them as like A simple mathematical formula gives a sequence of numbers which correspond to pitch information, which will be put into the circular buffer. The type of formula used is chosen here, and there are quite a few of them with very fun names here. So this is the formula named hope, love, life, age. And these are various parameters for them. Now, I'm not going to dive into these in great detail because they're covered in great detail in the manual. And frankly, I find the best way to get any sense of what they do is just to play around with them. So I've selected the byte beat equation love. Let's hear what happens when I send in gate information. I'll start the arpeggiator running on the key step. It's not going to be sending in any pitch information, just a gate here on the trigger 1. Let's go. And you hear that lovely melody being generated. That is entirely being generated by the algorithm in the Ornament in Crime using an equation called love. It's the equation for love. By just playing around with the equations and these parameters for the equations, it's possible to create some very, very interesting generative melodies. And of course, if you generate something that you like, you can again freeze the buffer and play around with it like we did before. Another source of randomness are integer sequences. Integer sequences are again generated sequences using sometimes mathematical formulas or other times equations or constants. In this case, for example, we are going to use the sequence containing the digits of pi to generate the values placed into the buffer, which we will then loop and manipulate to play the notes. Let's give it a go. Again, I'm just sending in gate values from the key step, no pitch information. So if you've ever wondered what pi sounds like, now you know. This is what pi sounds like when put through a sequencer. And again, I can freeze this buffer and then we can manipulate the sounds. I'm rotating the scale mask to change the actual quantizing of the notes. I can pitch it down or up and adjust the delay of which notes get sent out. Now, you don't have to use these outputs just to generate pitch information. You can also use them as modulation sources. For example, how about I send one of these outputs into the timbre of the plates oscillator as a modulation. So I'm just going to route output 3 here to that input. We'll dial up the attenuator. And there you hear that simply using the output as a modulation source is entirely possible. Now just be aware that the range of voltages coming out will be constrained by what you've set the buffer to contain and also by the input gain, which might give you too small a range for a very effective modulation. So you might have to play around with that. Now let me show you an example of how I've used the copier machine mode in Ornament in Crime to sequence the general CV using Shepherd mode on the general CV. Now this looks like a complicated patch. There's an awful lot of wiring going on here, but the basic idea is very simple. Output 1 from Ornament and Crime is just driving the pitch input here, input 4 of General CV. And that's setting the pitch of the piano sample that's going to be playing in a second. The other outputs, 2, 3, and 4, are modulating the different inputs on the General CV, and output 3 is also modulating the zone on the Mimeophone. So the way I've configured Ornament and Crime, it's a very simple configuration. It's just running 1 octave below middle C. Everything else is default, but what I did was I scaled the input by 0.5, so 50% input, which means the clock will come in here and the sample is coming in here on CV1, which I'm generating on Pam's new workout. I found the output from Pam's was too great a range and the notes were going far too high, so I just put an input gain on the input here, which meant that that was attenuated down. The idea here is that Pam's clocks the generator on input 1 and generates a random value, which you're seeing here on output 2. It's just a random waveform being generated by Pam's new workout. As you can see on the screen here on Ornament and Crime, each new value is being output here and then cycles its way down through the outputs as the buffer moves through the various values. In combination with the Shepherd mode on the General CV, you can get quite complex patterns. I'm sending a CV input from my manual switch here into input 7. I've configured that to control the scale. So by simply pressing this button here, I change the scale of the notes being played and the tone changes considerably. Watch. Now when I press it again, so this is just a nice way of getting some hands-on playability. I really like this little 4-step sequential switch which I got from ST Modular. The output from General CV goes through Mimeophone. I love the way Mimeophone lets me loop and weave sounds together. I tend to modulate the timing of the rate of delays using a stepped random from Pam's new workout. I also send a clock into the tempo input on Mimeophone here, which means that I can change the delay rate and have it in sync with whatever clock is playing. I then modulate the color CV input here, which changes the amount of the filter applied onto the delay echoes you hear throughout the sound. One of my favorite things to do is send a random trigger into the flip CV input. What this means is that as the track plays, you are randomly flipping and reversing the samples that are playing. This creates a lovely additional layer of complexity. Finally, I often turn on the skew input. What this does is it skews the echoes across the left and right of the stereo field, and you can create some very, very unusual stereo spread, which would be impossible to achieve if you were just playing normally. So that was just a very simple example of how you don't have to use Ornament and Crime Copier Machine for playing only oscillators. You can use it as a modulation source as well. So hopefully this video has given you some creative ideas of how to use Copier Machine. I've covered what it is and how it works, and some examples of how you can use it for patches. Thank you for watching, and don't forget to leave me some comments down below. Hit like if you liked what you saw, and if you didn't, leave me a comment down below and let me know why. And don't forget to hit subscribe for more videos in the future.